Welcome to lectures on problem solving and programming C. This is lecture 32 and the title of the lecture is user-defined data types. So far we have seen basic data types like integer, float, double, character, string, and arrays, right? So sometimes in many applications, for example, if you take date of birth has three fields. So it has day, month, and year. If you take an imaginary number, it has two fields, real part and imaginary part. So to define such a composite data types, we need to create our own data types by combining two or three existing data types. Let us see how to do that in C. For example, we need to create it. Suppose if I want to perform operations on real imaginary numbers, I can add imaginary numbers, multiply imaginary numbers, subtract imaginary numbers. So I can do that with basic data types only. But the thing is, I need to separate out the real part and the imaginary part and store them in a different variables. But actually, if you take one imaginary number, the real part of the imaginary number, the imaginary part of the both are related to single imaginary number. So that is, they should be stored together. That is why programming languages provides facilities to create composite data types, which we can combine two or more fields to create a new data type. For example, like that, suppose if you have a date, if there is a date of birth or date, so day has three fields, right? Day and month and year. So these three are related. Suppose if we take a single date, which date, month, and year are related to each other. So they should be stored together. So that is why C language and any other programming languages provides facility to create our own data types or user-defined data types or composite data types. Okay, let us see how we can do that in C. Imagine, let's say imaginary number, imaginary. C. So first thing, how do you create our own data type using the concept called structure? Struct imaginary. So this is how you create. Okay. So this is how many fields are there inside it. So int real part, int imaginary part. Okay. These can be real also. In real part and imaginary part can also be real. But for simplicity, I'm just using both are integers. Okay. Let us take hash include stdio.h. Okay. Let us say int main default return 0. Okay. So if I declare, I want to read two imaginary numbers and then perform their addition, right? So what I can do is declare. So what is the data type? Data type is this. Struct imaginary is my new data type. Instead of int, struct imaginary a comma b. Okay, these are two imaginary numbers a and b. Okay. Now next, as I told you, this is the new name for the newly created data type. Struct imaginary number. These two words forms the new data type. So alternatively, what I can do is I can use this something called type def struct imaginary struct imaginary as image type like this I can say, and then straight away I can use I'm creating a new name for these two words. Instead of two words, I'm just creating a shortcut image type. Okay, image type A and B. How do you define printf? Enter an imaginary number. So scanf. So usually people enter like this, no? So printf %d plus I %d. So 2 plus 3i or 3i, comma ampersand a dot rp, comma ampersand a dot IP imaginary. This is how you read. A has, this is A variable which is of imaginary type. It has two fields, RP and IP. How do you access them? A dot RP, A dot IP. This RP, A dot IP and A dot RP. Okay. Similarly, we can read one more imaginary number. One more imaginary number. So B dot RP and B dot IP. Okay. And then so image type C. Okay. C dot RP is equal to A dot RP plus P dot RP. Okay, right. Similarly, C dot IP is equal to A dot IP plus B dot IP. Printf sum is equal to sum is %d plus %di. C dot RP comma C dot IP. When you're displaying, there is no ampersand. When you're reading, there is an ampersand, very similar to basic data types. So let us do this, complete this, compile this. ECC imaginary dot A dot enter the imaginary number 1 plus 2i 2 plus 3i. Okay, so you see here 3 plus 5i. See 2 plus 1 plus 2 is 3, 2 plus 3 is 5. Like this. Like this, we can perform our own, create our own data type. Okay. For example, I can even create a date data type. Struct date int dd int int y. Right, like this. I can create data type like this. If I declare type def struct date. This is a new data type date. Suppose if I say that date D. Date D means it has date is a D variable which is of type date. D is a variable of type composite data type date which has three fields DD, YY. Okay, I can read like this. Printf enter a date in DD, YY format. Let's say like this. Okay, so scanf %d ampersand d dot dd ampersand d dot ampersand d dot YY. Okay. Printf. Let us display the date. %d d dot dd d dot d dot YY. Okay. Printf date is right. Let us run this. This is the imaginary number dot slash a dot out. Enter 1 plus 2i 4 plus 6i. Sum is enter a date in DDMF format. So 01, 02, 03, 2000. So date is 13/2000, right? 13/2000. Like this, we can store, we can create our own data types using C structures and then operate on them. We can pass structures to functions also. That is like we do pass integer data types, we can also pass user defined data types, and we can also return user defined data types. Okay. So I stop here. Thank you.